In this video, we are going to talk about method overloading. So, overloading a method means having more than one method with the same name. Okay, and you might think at first that that would cause some issues, and it can cause some issues with your program having two methods with exactly the same name. So they have to be different enough from one another that Java can tell the difference between the two. And how Java tells the difference between two methods with the same name is through the parameter list. That's that list of types and variables that is inside the parentheses in the method header. Okay, so if you have two methods with exactly the same name, they have to have either a different number of parameters, like maybe one has 2 parameters and the other method has 3, or if they have the same number of parameters, the types would have to be different. Okay, so let's take a look at an example of method overloading, and let me close this out. And that would be in chapter 6 and lecture code, and then message. Let's take a look at that first. All right, so here we have a class called message. It has one field up here, and that probably should be private. I forgot to add that on there. All right, it has a constructor, and this constructor just really is kind of one of the most basic constructors. All right, and here we have a method called display message. Okay, and then if you look, here is another method also called display message. So these two methods have exactly the same name. Okay, so that is an example of method overloading. So, like I said, with that can cause some problems. But what's inside parentheses, right? The parameter list, if that's different from one to the other, then Java is able to tell the difference between those two. And that's nice because if you want to, make different custom versions of a message, you can of a method, you can do that. Okay. Pretty easily. You don't have to come up with a different name or anything else like that. All right, in this case, Java can tell the difference between these two methods with the same name because this method has no parameters, right? In the method header here, there are no variables with types listed, whereas here we have one parameter in the parameter list. So Java knows because that these are different methods with the same name because of the different number of parameters. All right, let's take a look. Compile that. And really the only difference between these two, they both display the value of the field message up here. But this one will tack on a little extra string after the message. Okay. So let's take a look at test message very quickly. Here I create a message object. So the message would be hello. And remember how you call methods inside of an object. You put the object name and then a dot, right? And then the name of the message that you want to call and any parameters. So here in line 7, right, I am calling the display message. And you notice that there are no arguments, so Java automatically knows that it's this version of the message, display message method that we're calling. All right, in the next line, in line 8, you can see that there is an argument in this method call. And so Java knows, okay, there's one string argument, so Java is going to look for the display message version that has one string parameter, and that's this version right here. Right? When I run it, it looks like this. All right, So you can see on line 7 resulted in this, and in line 8 it resulted in hello with this extra message tacked onto the end. All right, let's take a look in Canvas and see how that would run, just so you can see the action. So here we create a message object. I'm going to hit the curved arrow so we can see all of the details. That jumps over to the message constructor in the message class. This line 7 copies the message to the field message. And back over in test message, we get our message object. Okay. Then in line 7, we call the display message method, and we're going to see Java's going to know automatically which version of the display message method to jump to, because there are no parameters in the parameter list. So you can see it automatically jump to this one, and we will display just the basic message. Okay. All right, and then in line 8, we are calling the display message method with one single parameter, right? So we're going to see that when we hit this curved arrow, it's going to know to jump over to this version, right, of the display message method, as opposed to this one right here. Okay. And now we're going to get that message hello with the extra message tacked onto the end. All right. So that is method overloading. So that's pretty convenient, because you can have two methods with exactly the same name, okay, that do slightly different things. So one useful area where you can use method overloading is with constructors. Constructors are methods, so they can be overloaded. And so overloaded constructors, you can use that to provide some flexibility when you create objects, right? So if you think about it, in chapter 5, we went where any outside class could create a blank object, right? We were using the default constructor. We hadn't talked about constructors at that point. And so an outside class could create a essentially blank class object with null values in there. And so then what we did was we added constructors in there in chapter 6. And so that required all of the information to be provided for the fields up front. Okay. So that is sort of at the other end. Not requiring any information is too relaxed, essentially, and really not safe, or it's not a good way to program, right? But then in the other situation where we have a parameter for each of the fields, that's kind of the other end. That's very rigid in saying, hey, you must supply all of the information up front. That's very rigid and doesn't allow for much flexibility. So one of the things you can do is to provide some flexibility when objects are created, and then you can kind of be somewhere in the middle between being really relaxed about things and really rigid and uptight about object creation. Okay. So as an example of this, let's take a look at the student class in chapter 6. Lecture code. Let's close these out. All right, so say in the student class, right, we're going to have a student class here, and we have a last name, a first name, and a student ID, okay? And you'll notice in this example, these methods, the constructors, are overloaded. I have a constructor here, and you can see because it is the same name as the name of the class, and I have a constructor here. Again, the rules for constructors say that the name of the constructor has to be exactly the same as the name of the class. So that means you don't have any choice about constructor names. So far in chapter 6, what we've covered about constructors, this is the standard constructor that we talked about. It has parameters for each of the for each of the fields up here, last name, first name, student ID, and it does the basic thing of setting each of the fields to the values passed to its parameters. Okay, so now let's say you're writing this for a college or something, a piece of software that keeps track of student information, and say the admissions department wants to use that, and so they might say, hey, well, when people apply to the college, I want to, of course, they're going to give their last name and the first name, but we don't really assign student IDs to people until they're admitted. But we still want to keep track of the people who applied to the college but have not been admitted. We just don't want to assign them a student ID. If you only had this constructor, then the admissions people would have to change their policies and their work processes to accommodate your software. And when you're writing software, you really don't want to do that. You probably want it the other way. You want to have your software adapt to whoever your client's business's process are, or whatever your client's business processes are. Okay, so what you can do in here, and what we're going to do, is add another constructor. Okay, so in this other constructor up here, this new one that we're going to add, we are only going to require a last name and a first name. And that's reasonable, right? Because anybody who is applying to the college has to provide their last name and the first name plus, some other information. But we're going to skip the student ID. Okay. So what we would do then is, instead of setting the student ID to what the actual student ID is, we're going to give everybody who has applied to the college but not been accepted to the college a student ID of 999, which is basically just a code, right, that we're going to use as a temporary student ID for somebody who has applied but not yet been accepted. And then once they get accepted, then they will be assigned a student ID. Okay? So this is sort of a default value. We don't know what the student ID is up front. Well, we're just going to give a student ID of 999 as a temporary. And then once you've been accepted, we'll change this to whatever your actual student ID will be. So that provides a little bit of flexibility, right? Now the admissions people don't have to change what they do, right? They don't have to figure out, okay, how are we going to assign these student IDs to people that aren't even going to be accepted, okay? Or they don't know who are going to be accepted. So anyway, this provides a lot of flexibility. Now we don't have to have all kinds of values, but at the same time, we still know that there's not going to be any null values in here. Everything is going to be set up the way we want it to. So that's kind of somewhere in the middle of the approach that we took in chapter 5, where we didn't set anything up when the object was created. And then the beginning of chapter 6, we were kind of insisting everything has to be set up. All of the fields have to be set up perfectly, like this. And so this is in the middle. The last name and the first name are going to be set up like they're supposed to be, but the student ID is not going to be, it's going to be set up, but to this value, which is basically represents the fact that their information is still being processed. Okay, so that gives some flexibility. All right, so now looking at this line right here, okay, this line right here is uses the this reference again. All right, so you can see we have this keyword this, but it's in a different way than this use of the keyword this. Okay, so this was for fields. Right? So when you have this and a constructor in here, right, or in a parenthesis in here, that's going to look for a constructor. Okay, and it's going to look at this parameter list like this, and it's going to find a constructor that has 3 parameters. The first one being the same as a string, the next one being a string, the same as this variable right here, and the third being an int right here. And of course that is down here at line 14. So basically, this line right here, this use of the this reference calls this constructor. Okay, you could put in this constructor, put this dot last name equals last name, this dot first name equals first name, and this student ID equals 999. You could do that. All right. So in other words, I'll go ahead and show that to you, but I'm going to delete it straight out of there. So this line I have right here, line 11, is essentially the same as, oops, hit the wrong button. As this. So here we're saying, hey, if you're just given a last name and a first name, then set the last name field to and the first name field to whatever you're given, and then set the ID field to 999. Okay. So this statement right here, line 11, is basically a shortcut for this. You've already done this work right here, right? So instead of doing that, you can just pass this last name, first name, and 999 to this constructor right here. So you are calling this constructor, all right? And so you would do that with this reference. I prefer to do this because why repeat yourself, right? This way is shorter and cleaner. You just have to understand what this reference does, and that's pretty straightforward, right? This just tries to find a constructor with these three parameters of these types, a string, and an int right here. All right. Okay, so let's see. Where's test student? Do I not have that? Let's see if it's this one. No, that's for another example. Okay, so let's write that really quickly so we can kind of see how that works. So I want to write a class that uses the student class that we just looked at to show you how that works exactly. All right, I think it was last name, then first name, and then okay. So here in the test student class, I am creating two student objects. Here I create a student object, Bob Brown. Yeah. Okay. With a student ID of 1. Okay. And then here I am creating a student object with just a last name and a first name, Diane Dinkins. And so she would basically represent somebody who had applied to the college but had not been accepted to the college. Whereas Bob Brown would basically be like a student who has already been accepted, a current student and everything. Okay, so let's see how that goes. So Control Shift R. And it looks like I did not save it in the right place. Oh, I forget the new keyword, that's it. Okay. So let's look at that again. Let's Control Shift R and see how that goes. Okay, so now here I'm creating a student object and I've got 3 parameters in here. So what Java is going to do is going to jump over to the student class and find the constructor with 3 parameters. So it jumps over here and you can see it had no trouble telling that apart, right? Even though we have 2 constructors, right, with exactly the same names, this one only has 2 parameters, whereas this one has 3. Okay? So it sets up our student object and boom, it's created. So that's kind of what we did at the beginning of chapter 6. All right, next up, we are going to create a student object by calling the constructor that has only 2 parameters. And we're going to see again, Java has no issues. It knows to jump to this one with 2 parameters, right? Both of type string. All right, and so now we get to this line, line 11, right? And so now what's going to happen is I am using the this reference with the parentheses, right? So what that means, Java knows, okay, I'm going to try to find a constructor that has 3 parameters in it. And sure enough, right, when I hit this curved arrow, you're going to see it's going to jump down to this one right here with 3 parameters. And you can see that one does the setup. So basically, this constructor is saying, just passing this information to this constructor and say, hey, you set it up, okay? So this constructor is doing the work here. But by doing this, we can provide this default value that says, hey, if there's no student ID specified, then give the student object a student ID of 999. And that way we can tell, if we want to search for all of the students who have applied but not yet been accepted, we can just do a search for a student ID of 999 or something like that. Okay. All right, and then so this method is going to complete. It's going to jump back to where it was called, which is up here on line 11. And then that completes this constructor here. So it's going to jump back to where it was called from, which is over in test student. And then it's going to create my object, and you can see it automatically, right, gave Diane Dinkins a student ID of 999 here. So this is a convenient way to provide a default method. That way we know as programmers, okay, we are requiring all this information for student objects to be created, so it's safer that way. But yet we are also at the same time with this other constructor providing some flexibility. So that is a use of method overloading when it comes to constructors to provide default values. All right, and I think that's going to be it. We already talked about the this reference, right? How that refers to a constructor in that class. Okay, so we will save this for the next video.